So section 13.6, directional derivative and gradients. Let's start with example 1. They ask you find the directional derivative of the function at P in the direction of the vector V. So here's example 1. We have the function f of x, y equal x cubed minus y cubed. And we have the point 0.63. And we have the vector v. I'm going to write down the vector v in the component form. So if you distribute square root of 2 on I and j, that's mean the vector is going to be square root of 2 over 2 and square root of 2 divided by 2. This is the vector. So the first thing before I start finding the directional derivative of the function at this point P, I have the point, I have to check the vector we have. Is that a unit vector? So before you start doing the rules, we have to check the vector if it's a unit vector. That's mean we have to check the length of V equal 1, which is square root of 2 divided by 2 squared plus square root of 2 divided by 2 squared, which is equal, is going to be 2 over 4 plus 2 over 4, which is equal square root of 4 over 4, which is equal square root of 1 and equal 1. That's mean the vector we have here, it's a unit vector. Be careful, sometimes they're going to give you example, the unit vector is not, the vector is not a unit vector, so you have to convert it to a unit vector. Now we're going to find the directional derivative to the vector v to the function f of x, y, which is equal, is going to be f sub x and f sub y times the vector v. Because the vector v is a unit vector, so we're just going to multiply by this one. And that's mean this one is going to be equal. The derivative of the function with respect to the x is going to be 3x squared minus the y is 0, because it's a constant. The derivative of the function with respect to the y is going to be 3y squared. Let's write down 0 minus 3y squared. And everything is times the vector v, which is square root of 2 divided by 2 and square root of 2 divided by 2. Then this one is going to be equal 3x squared negative 3y squared times square root of 2 divided by 2 square root of 2 divided by 2. Be careful, this is a dot product. The result of the dot product is going to be a number. That's mean when you do the dot product between two vectors, this one is going to be times this one plus this one times this one. So it's going to be 3x squared times, you can put the dot, times the vector, the first component, plus the second one times square root of 2 divided by 2. So the result is going to be 3 square root of 2 divided by 2x squared minus 3 square root of 2 divided by 2 y squared. And I can simplify this one because they are the same. So I'm going to factor out 3 square root of 2 divided by 2. And here is going to be x squared minus y squared. So this is the direction derivative with the vector v. Now we need to find that at the point Yeah, because they ask you to find at P. That means you're going to plug in the point. This is X, and here's Y. So the direction derivative on the vector V to the F, X is at the point 3, 6, and 3 is going to be 3 square root of 2 divided by 2. And here is going to be X squared. That means 36 minus Y squared. Let's plug in this one first. Minus 3 squared. 2 divided by 2. And here is 36 minus 9. You're just going to simplify this one. So just simplify 36 minus 9. It's going to be 27 times the 3. So just write down like this. You don't have to, you can't plug in as a decimal number. So just as an exact solution, you're going to plug in. Here we go. We're going to do exactly the same thing, the same steps with example 2. With example 2, find the directional derivative of the function at P in the direction of V. The main thing here, you just have to be careful when you find the derivative. So the second example is going to be g of xy is going to be square root of x squared plus y squared. And the point is P 3, 4. And we have the vector V is 7i minus 24j. So the vector, I'm just going to write in component form, which is 7 and negative 24. Okay. So let's work on this one. 7, negative 24. Okay. Now, again, before I start working on this one, I need to check the vector is a unit vector, because we have to work with the unit vector. So the length of V is equal square root of 7 squared plus negative 24 squared. That means it's equal. Let's check. Negative 24 is 24 times 24, so it's going to be 576 plus 49. 49 plus 576. And add 49 is going to be 625. So equal 625, and the square root for 625 is 25, is not 1. That means this is not a unit vector. So in this case, we have to convert V to a unit vector. Now, our unit vector, the new one, I'm going to say it's a U, which is equal V divided by the length. Then equal the vector V, which is 7, negative 24, divided by the length of V is 25. So our new vector is going to be U equal 7 over 25 and negative 24 over 25. So this is our unit vector, and 100% the length for this unit vector equal 1. So now we have the new vector, which is going to work with the function. Now our function is g of xy, which is equal the square root of x squared plus y squared. It's hard to work on this one. So I'm going to convert it to x squared plus y squared to the half. Now let's work to find the directional derivative of the function. The directional derivative of the function to the direction of the v vector for the g to the xy is equal g with respect, the derivative of g with respect to the x, the derivative of g with respect to the y, and times our unit vector, which is u. So that means this one is going to be equal. Now we need to find the derivative of g with respect to the x. I'm going to start from here. With respect to the x is going to be 1/2, the derivative of the outside, and the function times the derivative of inside, which is the derivative with respect to the x, 2x, and the y is 0, because it's a constant. And here's -1/2. Don't forget that. And the derivative of the function with respect to the y is going to be the same thing, half x squared plus y squared to the negative half times the derivative of inside, which is 0 plus 2y. And everything here times u, times the vector u, which is 7/25 and -24/25. Now let's simplify this one. This 2 goes with this one. So that means the left is going to be x, and this one goes down. So x over the square root of x squared plus y squared. The same thing here. This is the y. Cancel the 2 with this one. So y is going to be on the top. And this one, because it's negative exponent, so it's going to be x squared plus y squared times the direction vector, the unit vector, which is over 25 and -24/25. Now let's simplify this one. We're going to do the dot product. That means the derivative of v to the g of xy is going to be x times this one. So it's going to be 7x over 25 square root of x squared plus y squared plus -24 with the y, so it's going to be minus 24 y over 25 square root of x squared plus y squared. We have the same denominator here, so we can combine these together as 7x minus 24y, and everything is divided by 25 square root of x squared plus y squared. I think, yeah. Now we need to find the direction and derivative of the function at the point 3, 4. So the direction and derivative with the vector to the g at the point 3, 4 is going to be, we're going to plug in 3 and 4 here. This is x, y, so it's going to be 7 times 3 minus 24 times 4, and everything is divided by 25 square root of x squared, which is 9, plus y squared, which is 16, because the y, so y squared is 16. And here is going to be 25. Square root over 25 is going to be 5. Here is going to be 21 minus 24 times 4 times 4 is going to be 96 over, here's 25, and here's 25, square root of 25 is going to be times 5. That means this one is going to be 21 minus 96 is going to be negative 75 over 125. You can simplify it by 5. So it's going to be by 5 is going to be negative 3 and over 25. That's it for this example. So here's the wrong thing because we can divide both by 25. So it's going to be negative 3 over 5. Here we go, just put 5. That's it. So to find the gradients of the function at the given points, f of xy is 2x plus y squared plus 5 at the points. So the gradients of the function f, here's the symbol of the gradients for the function f is going to be f sub x and f sub y. That's mean this one is going to be equal. Here's f to find the derivative with respect to the x. So it's going to be 2x. That's mean 2. And this is 0. And the 5 is 0. For the y, to find the derivative for the y, this is going to be 0 plus 10y plus 0. That's mean the gradient, the function f is going to be 2 and 10y. Now to find the gradients of the function f at the point 1, 5, is going to be equal. X is already, there's no x here, so we're just going to keep the 2. And here is going to be 10 times y, which is 5. So it's going to be 250. That's it for this example. So we're just going to put 250. The vectors, and we're going to put 2, comma, 50. And it's supposed to be closed. Here we go. So example 4, find the gradients of the function at the point P, at the point 9, 0. We don't have to call it P. And here is our function, which is 18x e to the xy, and here is the point. Is that g of x, not f of x. So we need to find the gradients at this point. The gradients of the function g is going to be, here's the important thing, to the xy is going to be g sub x and g sub y. And this one is going to be equal. Now we have to find the derivative with respect to the x. So to find the derivative is the product of two functions. The product of two functions. So that means is going to be the first one times the derivative of the second one. So the first one is 18x times the derivative for the second one, because there is x here. Be careful with this function. Is going to be the function times the derivative of the exponent. The derivative of the exponent is going to be y, and 1 over x, the derivative of 1 over x is going to be ln x. So that you have to be careful. The derivative of 1 over x is ln x. We didn't finish from the first part. This one is going to be plus. The second one, which is e to the y over x, I'm using the product rule. times the derivative for the first one, which is 18. Now we're done from the x. Find the derivative with respect to the y. Is going to be, the x is constant, so we're going to keep it 18x. The derivative e to the y over x is going to be the same function, e to the y over x, and the derivative for the exponents for the y is 1, so it's going to be 1 over x times 1. Now let's just clean this one. So here is going to be 18x y e to the y over x ln x plus 18 e y over x, and this one is going to be cancel the x with the x, so it's going to be just 18 e to the y over x. Now to find the gradients with g at the point 9, 0 is going to be, we're gonna just plug in 9 and 0 here. So y is 0. So everything here is going to be 18, and here is the x, and here is the y. E to the 0 over 9, which is 0, ln x is 9, plus 18 e 0 over 9, and the next part is 18 e 0 over 9. This is 0, so everything here is 0. That means this one is going to be equal 18 e to the exponent 0 and 18 e to the exponent 0. This one equal 1, so it's going to be 18 and 18. That's it for this example. So we're just going to type 18, comma 18. So, example 5. Use the gradients to find the directional derivative of the function at p in the direction of v. So the first thing here on this example, we're going to look to the vector v, and we're going to check v equal -1 and 0. And the length of v is going to be the square root of 1 squared, or -1 squared, plus 0, squared, and it's going to be the square root of 1 and equal 1. So it's a unit vector. So before I start finding the gradients, I'm going to check the unit vector. It's a unit vector. If not, you have to convert it to the unit vector. Now the gradients for the function f is going to be hx and hy. That means this one is going to be equal two functions, so it's going to be the product rule. That means the first one times the derivative of the second one. The first one times the derivative for the second one. So it's going to be e to the x -6x times sine y. Oh, we need to find the derivative with respect to the x. This is 0. Let's do it. Times 0, because it's a constant, plus the second one times the derivative for the first one with respect to the x is going to be negative 6 e negative 6x. I did the chain rule of the first one. Now let's do the chain rule with the second one. The first one times the derivative for the second one to the y, so e negative 6x times the derivative for this one with respect to the y is going to be cosine y plus the second one sine y times the derivative for the first one is going to be 0 because I'm doing the derivative with respect to the y. So this is 0, this is 0. That means the gradient to the function f is going to be equal sine y or negative 6. Let's write down the e function first. Doesn't matter which one you're going to write down first. Negative 6 e negative 6x sine y, and the second one is going to be e to the negative 6x cosine y. So now this is okay. Now let's simplify this part because we have the point. So it's going to be plug in the point, the gradients for h at the point 1 and pi over 2 is going to be negative 6 e negative 6 times 1 sine pi over 2. And here is e negative 6 times 1 cosine pi over 2. Cosine pi over 2 is going to be 0, and sine pi over 2 is 1. So now this one is going to be equal negative 6 e to the negative 6. This is 1. On the other side, this is 0 times anything is going to be 0. So this is the gradient for h. Now to find the directional derivative for h is going to be, we're going to multiply the gradient by the unit vector. So here is the gradient, which is negative 6 e to the negative 6, 0 dot product with the unit vector, which is negative 1 and 0. And the result is going to be, it's a dot product. So this one times this one is going to be negative 6 e negative 6 times negative 1 plus 0 times 0. We can't put the dot product here. That means it's going to be 6 e to the negative 6. That's it for this example. So we're just going to plug in here 6e to the exponent negative 6. Here we go. Use the gradient to find the directional derivative of the function at p in the direction of pq. So the first thing we need to find, if you look here, there is no unit vector. We have 2 points. And our unit vectors is going to be with the direction with this vector. So let's start working on the vector. Then we're going to find the gradients. I have PQ. Here is the direction of PQ. So let's find PQ. PQ is going to be Q minus P. That means it's going to be 0 minus 6 and 0 minus 24 and 0 minus 0, which is equal negative 6, negative 24, and 0. But if you look to this one, it's not a unit vector, but we have to check. Maybe it's going to be a unit vector. So to find the length of PQ is going to be the square root of negative 6 squared plus negative 24 squared plus 0 squared. And this one is going to be equal 36 plus 24 squared. Negative 24 squared is going to be 5, because we found it before, 576. And this one is going to be square root of 612. And the 612, it's 4 times 153. So this one is going to be square root of 153 times 4. And this one is equal to square root of 153. This is not equal 1, so it's not a unit vector. So our unit vector is going to be our vector, which is P of PQ over the length of PQ. Then it's going to be equal negative 6, negative 24, and 0 divided by 2 square root of 153. And then this one is going to be equal negative 6 divided by 153. Negative 6 divided by 2153, and negative 24 divided by 2153, and you can simplify it, and 0. You can simplify this one, and let's see how we can keep it like this. But if you simplify it, it's going to be negative 12 over 153. And here is going to be, yeah, because we can simplify the 6 too. So our unit vector is going to be negative 3 over square root of 153. And here is going to be negative 12 over square root of 153 and 0. So here is our unit vector. Now we just need to find the gradient and multiply the result by this unit vector. So the gradients for function g is going to be g sub x, g sub y, and g sub z. And this one is going to be g sub x. We need to find g with respect to the x. That means y and E5z is a constant. So the result is going to be y E5z, because x, the derivative of x is 1. If you want to do the chain rule, it's going to be the same thing. Let's do times 1, which is the derivative of x. G sub y, now x and e is a constant. So it's going to be x E5z, and the derivative of y is 1. For the z, that means it's going to be x and y constant. So it's going to be xy E5z times the derivative of 5z is 5. That means this one is going to be equal y E5z and x e 5z, and here is going to be 5xy e 5z. So we're done. We found the gradients. Now we're going to multiply the point P. Let's multiply the point P, 6, 24, and 0. G at the point 6, 0, 6, 24, and 0 is going to be 24, which is the y, e 5 times z is 0, so 0. And here is x is 6, e 5 times 0 is going to be 0. And the last one is going to be 5, x is 6, y is 24, and e to the 0. And this one is going to be equal. This is 1, so it's going to be 24. And here is going to be 6. And 5 times 6 times 24 is going to be 720. So here is our vector. The gradient at the point 6, 24, and 0. Now the last step, the derivative, the directional derivative of v to the fraction g is going to be the gradient, which is 24, 6, 720, times 24. I'm just checking. 6 times 5 times 24. Yes, 720, because it's a really big number. Times the dot product of our unit vector, which is -3 over square root of 153, and -12 divided by square root of 153, and the last component is 0. It's a dot product, be careful. So this one is going to be this one times this one plus, so 24 times -3. 24 times -3 is going to be -72 over square root of 153. And here is also negative, but 6 times 12, 6 times 12 is going to be 72 also. So this is going to be minus 72 over square root 153. Negative, okay. Six. Okay, and the last one is going to be just 0. Plus 720 times 0 is going to be 0. So the result is going to be 72. You're gonna add it with 72. So 144. That's mean -144 divided by 153. That's it for this example. So we got right. Example 7, find the gradients of the function at the given point. Then they ask you to find the minimum value. So example 7, they ask you to find the gradients of the function at the given point. So the gradients of this function at this point, that's mean the gradients of the function f is going to be equal f sub x and f sub y. And this one is going to be equal, with respect to the x, this is going to be 2x plus 2y, because the derivative of x squared is 2x. The derivative of 2xy, 2y is a constant. The derivative of x is 1, so 2y. And the derivative of x with respect to the y, this is 0 plus with y, so just the constant, which is 2x. Then is going to be 2x plus 2y, and here is just 2x. The gradient of the function f at the point 4 and 2 is going to be equal 2 times 4 plus 2 times 2 and 2 times 4. So it's going to be 8 plus 4, and here is 8. And this one is going to be 12 and 8. So this is the 12, 8 is the gradient at this point. We need to find the maximum value of the directional derivative. Directional derivative, it's a vector. If we need to find the maximum value, that means the length for this vector. So just let's go on to find the length of the gradient of the function f, which is equal to the square root of 12 squared plus 8 squared, and this one is going to be 144 plus 64. And I think we can simplify it. 144 plus 64 is going to be 208. Let's find the square root of 208, because that's mean is going to be the square root of 16 times 13, and it's going to be 4 square root of 13. That's it for this example. So here is going to be the vector 12, 8. And here is going to be 4 square root of 13. Here we go. So now with this one, we need to find the gradient of the function at the given point. That means the gradient for this function f is going to be f sub x and f sub y. And that means this is equal. The derivative with respect to the x, but I'm using the quotient rule. So it's going to be the bottom part times the derivative of the top part, which is with respect to the x is going to be 1. So it's going to be y plus 1 times 1 minus top part times the derivative of x from the bottom part, which is 0, over y plus 1 squared. This is for the first part with respect to the x. Now we're going to do the same thing with respect to the y. So the only difference is using the quotient rule. Now the bottom part, which is y plus 1 times the derivative of the top part with respect to the y is going to be 2, because the x is 0, is a constant, minus the top part, which is x, plus 2y times the derivative of the bottom part with respect to the y is going to be 1. And everything is over y plus 1 squared. So now let's keep going. Simplify this one. The whole thing here is 0. Cancel this one with 1. So it's going to be 1 over y plus 1 on this side equal. Here we have to distribute here and then distribute here and combine the like terms. So it's going to be 2y plus 2 minus x minus 2y and everything over. There's something because here's 2. Yes, y plus 1 squared. Combine the like terms. So this one is going to be 1 over y plus 1. And here is going to be 2. This one cancel with this one. So it's going to be 2 minus x 2y. And here is, when we distribute, this one is 2y minus 2. Okay. So it's going to be, and here is negative x. So it's going to be just 2 minus x. Over y plus 1 squared. Let's keep going. Now we're going to find the gradients at the point. At the point 1 and 1. So it's going to be 1 over 1 plus 1. And here is going to be 2 minus 1 over 1 plus 1 squared. And this one is going to be equal 1 over 2. And 2 minus 1 is going to be 1 over 1 plus 1 is going to be 2 squared is going to be 4. So that's our gradients at this point. To find the maximum value, that means we're going to find the length for the gradients to the function f, which is equal square root of half squared plus 1 over 4 squared is going to be 1 over 4 plus 1 over 16, and it's going to be square root of 16 over 4. Multiply both by 4. No, 4 over 16 plus 1 over 16. Just find the common denominator. So it's going to be square root of 5 over 16 and this one is going to be 1 over 4 times square root of 5. 1 over 4 times square root of 5. This is the maximum value. So this is right, what we got. Now we're going to do the same thing with example 9. We're going to assume that the unit vector, our unit vector u, is going to be with these two components, u1 and u2. That means we can multiply the gradients with the unit vector. So the gradient of the function f at the point 9, 5, total product with the unit vector equals 0 because they are orthogonal. That's what they're telling you. With the unit vector equals 0. That means the gradients, the components for the gradients is going to be the gradients for f sub 1 and f sub 2. times the unit vector, which is u1 and u2 is going to be equal 0. From this one, we're going to get equations. It's a dot product, so it's going to be, this is just the chart. This one times this one plus this one times this one is going to be the first equations. So it's going to be delta F1 U1 plus delta F2 U2 is going to be equal 0. This is the first equation. Let's check now with numbers to find the real first equations. Now, the first thing we have to do, we need to find the gradient. That's mean delta sub f is going to be f sub x and f sub y, which is equal. Yes, then we're going to plug in at the point. Let's find the f sub x. F sub x, this is 0. This one is going to be negative 1 over 2. And this one is 0. So it's going to be negative 1 over 2. Let's write down this first, so you're not going to get confused, which is 0 minus 1 over 2 minus 0. And f sub y is going to be 0 minus 1 over 7. That's mean the gradient of f at the point, because we can plug in x and y, because there is no x and y. So at the point 9, 5 is going to be negative 1 over 2 and negative 1 over 7. Now I have the gradients here. I'm just going to plug in this gradient here to find the first equations. That's mean this one times u1 is going to be negative 1 over 2 u1 plus, that means going to be minus 1 over 7 u2 is going to be equal 0. Now this is my first equations. I'm going to put this one a star. This is the first equations I'm going to work on. Now how are we going to get the second one? Because our goal is to find the unit vector. That means I need to find u1 and u2, the components for this new vector. It's a unit vector. That means the length for these components or for the unit vector equal 1. So the length for the unit vector equal 1. That means the square root of u1 squared plus u2 squared equal 1. Square both sides. So it's going to be u1 squared plus u2 squared equal 1. This is the second equations. Now I have two equations. I'm going to solve this one. Let's solve the first one and plug in here. From the first one, I can get, I'm going to solve it for, we can do it here. So for 1, we're going to solve it for u2, or let's do it for u1. u1, negative 1 over 2, u1 equal 1 over 7, u2. Then multiply by negative 2. That means u1 is going to be equal by negative 2, so it's going to be u1 equal negative 2 over 7 u2. Now here is the value of u1. Plug in this one, substitute in 2. From 2, we're gonna get here's 2. We're gonna plug in u1 here. So it's gonna be negative 2 over 7 squared u2 squared plus u2 squared is going to be equal 1. Now square these two, it's going to be 4 over 49 u2 squared plus u1, plus u2 squared is going to be 1. Now we have to add 4 over 9 with 1. So 4 over 49 plus 1, which is equal 4 over 49 plus 49 over 49. Find the common denominator. So it's going to be 50 over 49. That's mean 50 over 49 u2 squared equal 1. So in this case, u2 squared is going to be multiplied by the reciprocal, is going to be 49 over 50. This is the square. Now to find u2, take the square root. So it's going to be plus or minus square root of 49 is 7, square root of 50, which is 2 times 25. So it's going to be 5 square root of 2. We have a plus or minus. Now let's go back and plug in this one here. In this case, u1 is going to be negative 2 over 7 times plus or minus 7 over 5 square root of 2. And it's going to be careful. Cancel the 7 with the 7. Negative times positive is going to be positive. Sorry, negative times positive is going to be negative. Negative times negative is going to be positive. That means we have two solutions. When u2 is positive, u1 is going to be negative. When u2 is negative, u1 is going to be positive, the opposite with the sign. And 2 times here is going to be 2 over, because we cancel the 7 with the 7, 5 square root of 2. So we found u1 and u2. Two solutions, u1 for u, 2 values for u2 and 2 values for u1. We didn't finish. So now I can't plug in the result because when I work on this one, I use the point 9.5 and the original point is 9.4. But we're gonna keep going. So I have 2 values. What you're gonna do, you're going to say, here's my unit vector is going to be, we have 2 values. You can choose u1 is negative 2 over 5 square root of 2. And you have to choose u2, the positive one, 7 over 5 over square root of 2. Or you're going to choose u is u1, you're going to choose the positive one, which is 2 over 5 square root of 2. And then you're going to choose u2 is the positive one, the negative one, the opposite sign. That's mean negative 7 over 5 square root of 2. To find the direction derivative, choose one of these unit vector. Both is going to be right because we have 2 options. So the direction, I'm going to choose the same point, but I already chose different points than this one on example 9. So you're going to do the same steps. That's mean G, U at the point 9, 5 is going to be negative 1 over 3 and negative 1 over 2. But we got the gradient and negative 1 over 7. And everything is dot product with one of these u. Which one you're going to choose? Both is going to be right. Let's choose the first one. of 5 square root of 2 and 7 over 5 square root of 2. Then it's going to be dot product. That means this one times this one. So it's going to be, you're going to say negative 1 over 2 times negative 2 over 5 square root of 2 and the plus negative 1 over 7 times 7 over 5 square root of 2. Simplify this one. This is canceled with this one. Negative times negative is going to be positive. So it's going to be 1 over 5 square root of 2 plus cancel 7 with the 7. It's a positive, so it's going to be minus 5 square root of 2. And the result, we have the same denominator, 5 square root of 2. 1 minus 7 is going to be negative 6. So you're going to do the same thing, but you're going to choose different point. And if you choose the second unit vector, it's going to be the same result. So don't worry about that. Both is going to be right. So now, for example 10, we're going to do the same thing. They ask you to find a normal vector to the level curve f of xy equals c. At the p, we already have all the information. That means we're going to find the gradient with f to the point xy equal f sub x and f sub y. Which is equal f sub x, this is 0, is going to be negative 4. And f sub y, this is going to be negative 9. Negative 6. Because there is no xy to plug in, so that the gradient of f to the point 0, 0 is going to be negative 4 and negative 6. That's what they ask us. Let's check that. As a vector, we're just going to say negative 4, comma, negative 6. But it's supposed to be orthogonal to this point with the curve. So the curve, the level curve is going to be equal 15. That means this one equal 15, and you're going to solve it. You're going to get negative 4x minus 6y equals 0. Yeah, but that's it. That's the only thing they ask, to find the gradient at this point, at the point 0, 0. So if you solve this one with the curve and plug in the point 0, 0, you're going to get both sides equal 0. Let's check that. This is the solution. You don't have to do it more, but if we need to check at the point 0, 0, and the curve is 15, that means the gradient is equal to the curve. And that solve it. That means 15 minus 4x minus 6y equal 15. Then this one, you're going to move it to the other side, so cancel. That means negative 4x, because we need to find at the point 0, 0. Negative 4x minus 6y equals 0. Plug in the point 0, 0 is going to be negative 4 times 0 minus 6 times 0 equals 0, and we get 2 equal sides. About this one, you don't have to worry about this one. They ask you to find the gradients. Just go ahead and find the derivative sub x, f sub x, and f sub y, and that's it. If you have X and Y here, you have to plug in the point. But there is no X, there is no Y, so go ahead, that's it.